For our next speaker, we're going to be talking about cloud-enabled safety algorithms for heavy-duty commercial vehicles. I was trying to find a link to sustainability, and it turns out there is one, because if you get this right, you reduce the amount of space required, you make your vehicles lighter, and you can actually load them better and be more efficient on the road. So please make Philipp Meyer-Rössler from ZF welcome with a nice round of applause.
Thank you very much. So maybe you're wondering why Tier 1 is going on stage on a startup convention. This project was set up as an internal startup. So by doing innovation, not in a corporate manner, but for emerging and transformational ideas, doing that in another way in a big corporate environment is very beneficial, because you do not lose speed and you get to a maturity that is then already applicable and sellable to customers. So in general, electric vehicles are a mega trend. The same holds true for commercial vehicles as well, and the same benefits apply. You can see here on the screen zero local tailpipe emissions, low noise signature, and so forth. That's everywhere. And the complexity of the vehicles is also reduced by having a lot of batteries, a motor, an inverter that's not shown on the screen, and especially for commercial vehicles above a certain weight, you have this high voltage brake resistor. More on that in the next slides. So the regenerative braking can be used to comply or cope with a UN regulation that is put in place, basically TLDR, for preventing the brakes from overheating. So if you're going down a downhill slope, you need to keep a constant speed without using the friction brakes. That's the intention of it. But it comes with a catch. And going back 2 slides to the brake resistor, this is implemented in this vehicle. So traditionally, you would start charging at the top of the hill, and until the vehicle is fully charged, you would deploy it and drive downhill. So the vehicle starts, and as soon as these endurance brakes kick in, the battery is full. What to do with the surplus of energy? The vehicle now is dissipating that as heat to this brake resistor. It's basically a heating element that dissipates the energy as heat. So it cannot be facilitated for driving purposes. Our approach now is, at the top of the hill, think about where you're going. So before you start charging, you ask our cloud service what the maximum state of charge should be. And as soon as the vehicle deploys, after it charged up to that level, it starts going downhill, recuperates, and the whole energy can be stored into the battery and facilitated for driving. So it's more sustainable than the hardware-based solution. But I like to emphasize this is a safety-related feature. The sustainability is a byproduct. So how do we achieve that? What's happening behind the curtain? I have a little animation on that. So you saw on the last slide, there's a request to the cloud. We then identify the location of the vehicle. We have pre-calculated every critical section on the world map for it. And by identifying the most critical one, which basically is the most energy efficient one, we can then calculate, and we do that. We simulate it in a cloud environment along the route, what amount of energy is used and what amount of energy can be recuperated. And this leads to basically a simple math to say, okay, what is the charge limit I need to apply at the top of the hill? This then gets communicated back to the vehicle, and for the current state as we implemented it, it happens within 3 seconds. And that's the reason we put it to the cloud. There's a lot of computing involved to do that. And doing that in the vehicle is not very efficient, and it's costly. So falling back to the cloud, or shifting this functional safety mechanism to the cloud, has the benefit of upscaling. And in addition to that, we already have a green light from the German Federal Ministry of Transportation and Digital and Transportation, the other way around, and from the TÜV Rheinland. So this is not only concept, it's already implemented in the cloud. We achieve that by redundant instances, because it is a highly available service. It needs to be highly available service. It has a tailor-made routing algorithm, so everything in this service is bespoke, and the amount of data that's stored in the cloud can be updated on the go. Additionally, it's based on the vehicle energy consumption tool that manufacturers need to provide their carbon footprint with. So you can kill two birds with one stone here by using the same set of data you need to use for your emissions clearance for brake system homologation. And as you can see on the bottom here, also something I like to emphasize, it's not only for trucks, it's also for buses, so every commercial vehicle above 12 tons. If you like to partner with us using this solution in your vehicle, we have two different implementation models. You can either connect to the ZF cloud, where everything is already implemented and can be addressed, and you would channel the service through your cloud and your telematics. Or, since this is a Docker container, you could also use it in your cloud and get differential updates once in a while. And that basically concludes my presentation here. So the benefits are a more lightweight vehicle with reduced components, so you have more space, more cargo capacity. That could mean people, that could mean goods, and in addition to that, we can be adaptable with the software implementation, so if there's a new road constructed, we update the map material in the cloud without having the need to update the vehicle. And that's also quite interesting because that has never been done before. So we're doing pioneering work, putting a functional safety-related service from the vehicle into a cloud environment. Yeah, thank you very much.
Thanks so much, Philip.
Are there any questions? I think I'm quicker
Yeah,
than
you're welcome to have a question, yeah. Does anyone have questions from the audience?
Okay.
I have a question for you then, seeing you would like a question. Where did this come from? Because for me, it's interesting. I often think about, you want hardware changes to make a sustainability or a safety effect. So where did the idea come from for braking in hills?
The idea basically came from that we investigated the amount of situation where this occurs. Mm-hmm. And it comes down to 1% of European roads based on the regulation requirements, and almost 5% of customer requirements in terms of energies that need to be recuperated. And we thought, okay, why would you carry this heavy component with you when you rarely use it? Yeah. If there's a fleet or even a bus operator in a flat plane, he needs to have that component in to comply to the regulation. And we also talked to the UNECE guys, and they said, your solution is compliant, you can use it, and that's the beauty of it. You reduce the amount of components, the weight, the packaging by a simple software.
It's fantastic. It's a great example of innovation in the cloud. So thanks so much, Philip, for your presentation.
Thank you very much.